Hello everyone. Today we are going to talk about truth tables, which are tables that help us determine whether a certain logic statement can be regarded as true or false. Now, in today's discussion, we will specifically talk about negations, conjunctions, and disjunctions. So these are some of the connectives in logic statements that we had learned about previously. There are two other connectives, the conditionals and biconditionals. Those we will discuss at a later point. For today, we will talk about truth tables for negation, conjunction, and disjunction. So if you recall, negation is not, the not statement. So any statement that has the word not or false in it represents a negation. Then we have conjunction, which is the and statements that are connected together with and or but. Those are conjunctions, and disjunction is the or statement, right? So when two or more statements are connected by the word or, those would be regarded as disjunctions. Now let's begin by constructing a truth table for negation. Now, negation implies the not statements, and the symbol that we use to denote the not is this tilde symbol. Another thing about negation is that it works on a single statement. So you can negate a single statement, or rather a single list of truth values. So what do we understand by a list of truth values? When we have a statement, let's take a statement which we have symbolized by the letter P. This statement can take one of two truth values. It can either be a true statement or it can be a false statement, correct? So when we negate a statement which is true to begin with, upon negation, it will become a false statement. It will become just the opposite. If it was a true statement initially, it will become a false statement. If the statement was false to begin with, when we negate the statement, when we negate P, it will take the opposite value. That means it will become a true statement. All right. So that is the truth table for negation. It's a fairly simple and easy to remember truth table. All right. We will now construct the truth table for the conjunction, which is the and statement. So the word and would combine two or more simple statements, correct? Just like the disjunction, which is the or statement, there's always two statements involved. And when we start building the truth table, we have to first list all possible combinations of true and false that the two statements can take. So since we will be working with two statements, I'm going to list one statement, or denote one statement as P and the other statement as Q. And then I'm going to list all possible combinations of true and false values that the two statements can take together. All right, so first I'm going to give you a process of coming up with all possible combinations of true and false for two statements. All right, and that process is going to work for 3 statements, 4 statements, or as many number of statements you are working with. In this case, we'll work with 2 statements. So the first thing to know is that the number of rows, the number of combinations you should expect for 2 statements will be 2 to the power n. N being the number of statements you're working with. All right. So in this case, we are working with P and Q, 2 statements. Therefore, it's going to be 2 to the power 2, which is going to be 4 rows. So we will have 4 rows of true and false combinations, unique combinations. If we were working with 3 statements, then n would be a value of 3. N is the number of statements that we have. So it's going to be 2 cubed. So we would have 8 rows, 8 unique combinations of true and false. So since we are working with just 2 statements, the number of rows we can expect or we should have is 4. Correct? Now, how do we come up with the combinations? All right. So the best thing to do is start with the rightmost statement. In this case, Q is the rightmost statement. So over here, start with the true and then alternate. All right. So true, false. And we will have 4 rows. So we are going to go like this. True, false, then true, false. All right. And then to populate the truth values for the statement to the left, which is in this case P, just double the sequence with 2 trues and 2 falses. All right. So over here in the rightmost column, we just alternate once. So true, false, true, false. Over here, just double the number of trues and double the number of falses. So it's going to be T, T, true, true, followed by F, F, false, false. All right. So now we have all the 4 combinations. If you had another statement, let's say R, then you would double the number of trues, double the number, it would be the double of the number of trues and falses you had to its right. So for P, we had TT. So when you double 2, it'll become 4, right? So you would have 2 T, 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 and then F, 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 F. We would have, in that case, when we work with 3 statements, in that case, we would have 8 rows, correct? So it would fill up 8 rows. So anyway, I'm going to delete this column for R because here we are working with just 2 statements. So now that we have all our combinations set up, we can go ahead and evaluate the truth values for AND. Now this is how the truth values for AND statements is calculated, all right, or is evaluated. The only time that you will return a true, that you will get a true from 2 statements, is when both the statements are true. That's the only time that an AND returns a true. Otherwise, even if one is a false, even if one statement is a false, it will return a false. All right. So T, T, when you have both T's, then you should get a T. TF, true, false, returns a false. False, false, true, returns a false. And false, false will also return a false. So the only time in an AND statement that you end up with a true is when both the statements are true. All right, so that's the best way to remember. Now let's construct a truth table for the disjunction or the OR statement. Again, ORs combine multiple statements, 2 statements. Therefore, we are going to have P as well as Q. All right, so I'm going to write again here P and Q, and the symbol for the OR is this V. So we are going to evaluate P or Q, the truth values for P or Q. However, we have to first set up the combination of true and falses for P and Q. Again, we'll follow the same process. For the rightmost column, just alternate the true and false values, right? So it's going to be true, false. So it's going to be TF, TF. And then for the statement to the left, we will just double the number of trues and double the number of false. All right, so it's going to be TT and then FF. So 2 trues followed by 2 falses. And now we will go about evaluating the truth values of these combinations. For the OR statement, the only time that we get a false, the only time that an OR will return a false is when both the statements are false. Otherwise, it'll always return a true. All right, so based on that, T and T, so T or T, true should return a true. True false should return a true. False true should return a true, but false will return a false. All right, so again, to remember the truth table for the OR statement, keep in mind that the only time that an OR will return a false will be when both are false. In all other cases, as long as one of the statements is a true, it will return a true. All right? Now, if you were to be given an actual statement and be asked to create a truth table for it, the way you would go about it is first read the statement carefully and then determine whether it's a statement that has negation or conjunction or disjunction, that is a not or an and or an or, and based on that you will be constructing the table, right? So over here, when we read the statement, which is apples are a good source of fiber and oranges are a good source of vitamin C, we see there are 2 simple statements within this compound statement, and the connective here is and, correct? So that makes it a conjunction, and we will have to use the truth table for the conjunction when we work on this. So let me quickly work through this. It says apple are a good source of fiber. That's the first simple statement in this compound statement. So I'll call that P. And the second part of the statement is oranges are a good source of vitamin C. That's the other simple statement. So we'll call that Q. And you will be constructing the table as P and Q, correct? So this table is going to be exactly the same as the table we constructed up here, all right, when we worked on the and truth table. It should be identical to that, all right? Now, while I'm going to leave you to complete this particular example, because it's a very straightforward example, it's going to be the same identical truth table as this and table. So the work has been done for you. You just have to copy it down here, all right? Copy and write it down here. However, for the next example, I will work it in its entirety because that particular example will contain or will involve 2 connectives, all right? So let's go to that example. The statement is, it is false that Mr. Farinelli is the president or that Ms. Chow is the treasurer. So as we note here that this has multiple connectives, one of them is the or disjunction, and there's also negation involved. Right at the beginning of the statement, it says it is false. So this involves negation and this involves a disjunction. All right, so this table is going to be a little bit different. It's not going to be as straightforward as the previous example, as in the previous example. All right, so let's work through it in its entirety. The first step would be to again break it up into 2 simple statements. correct? So the first statement is Mr. Farinelli is the president, and we're going to denote that with a P. And the next one is Miss Chow is the treasurer. That's going to be the Q, correct? So write it down. All right, so P colon Mr. Farinelli. Mr. Farinelli is the president. And then the next one is going to say Q colon, and then Miss Chow is the treasurer. Is the treasurer. Again, when you write the simple statements, make sure you do not use any connectives, negations, disjunctions, etc. All right, so now that we got the two simple statements, we have to write this entire compound statement in symbolic form, correct? So we are going to write it as P, all right? P, this is P, this is Q. So it's going to be P or Q, and that has to be negated. So it's going to be P or Q for just this part of the statement. So I'm going to surround it with brackets. And then we have to negate it because the statement starts saying it is false. So we have to use the negation tilde symbol. All right, so this is the symbolic form of this entire statement up here, correct? So now we have to go ahead and build a truth table. We'll start by first listing all the possible combinations of true and false for these two statements, all right? So what was the process that we learned about? First thing is, if you're working with two statements, then the number of rows of true-false combinations would be 2 to the power 2, which would be equal to 4. All right, so the formula is 2 to the power n, where n is the number of statements that with which you are constructing the truth table. All right, so if you were working with 3 statements, it would be 2 to the power 3, therefore 8 rows, 8 combinations of true and false, correct? So we know there are going to be 1, 2, 3, 4 rows. However, how do we create the combinations at this point? Again, recall we said that start with the rightmost statement and just alternate true and false 4 times. So here we have true, false, correct? So that's for Q. And then go to its left and double the number of trues and double the number of false, correct? So you're going to write it as true, true, and then double the number of false, 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 all right, until you complete all the 4 rows, okay? So now in the next column, or for the rest of the columns, we just have to take this symbolic statement and write it down. So we are going to have a negation, and at this point, let me use a different color. We are going to use a negation and then P and then or, correct? This or symbol for disjunction, and Q, and space your work so you can complete the table in a neat and clean manner without it getting cluttered. All right, so in the next step, first we have to work with brackets. Whatever is within the brackets needs to be evaluated first, right? So I'm going to list all the P values, T, T, F, F again, all right? So it's going to be T, T, F, F for P, and Q was T, F, T, F, correct? And now we have to do the evaluation of the disjunction. Now, again, recall that for an OR truth table, the only time that it will result in a false is when both statements are false. Otherwise, it will always result in a true value, correct? So again, let's do this. Under the OR column, I'm going to write true, true should return a true. True, false should return a true. False true should return a true, but false should return a false. All right. So this is the evaluation of the or table. All right, or truth table, the disjunction. So now that we got the or calculated, we have to negate all these values. So let me highlight that these are the values now that we are dealing with. So we have to negate all of these values and write it under this tilde symbol, negation, because it's not P or Q. So in negation, the true becomes a false and the false will become a true. So when we complete that, this is how it's going to look like. So this true is going to become a false, this true is going to become a false, then true is a false, and the false becomes a true. So the final result, the final evaluation of this or truth table is this column here under the tilde. So it's going to be F, 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 T. All right. So this is how you will go about working on truth tables when your statement has multiple conjunctions or rather multiple connectives, negations, and so on. All right.